What do you think will happen if I add my sodium-potassium alloy called NaK to concentrated nitric acid? Let's find out. For this redox reaction, we'll use concentrated 16 molar nitric acid. We'll use a test tube, a stand, and this is my sodium-potassium alloy. It's abbreviated as NaK. It's stored in mineral oil because it's so reactive even with moisture in the air. The first step is to heat up the NaK so you get a nice, even ball of sodium-potassium alloy. After decanting some of that mineral oil off the top, you can see I have a nice blob of sodium-potassium alloy. Next, I'm going to use a syringe to draw some of this out to put into my test tube. There it is. Okay, and now we're ready to add that to the bottom of our test tube. For safety, place your test tube and stand on a flame-retentive blanket behind a blast shield. Okay, and now we're ready to add just a drop of nitric acid. Here we go. This is why you want to use a flame retentive blanket. Look at that. Here's the balanced equation for this amazing redox reaction. We begin with the reactants, sodium-potassium alloy and nitric acid. We have 2 moles of sodium-potassium, that's the 2NaK, and we have 4 moles of nitric acid, that's the 4HNO3. When those are combined, we get the products sodium nitrate, potassium nitrate, and hydrogen gas. We have 2 moles of sodium nitrate, that's the 2NaNO3. We have 2 moles of potassium nitrate, that's the 2KNO3. And we have 2 moles of the diatomic molecule of hydrogen gas, that's the 2H2. Now this is also a reduction-oxidation reaction. We can see that the alloy of sodium-potassium is being oxidized. As it's losing electrons, its oxidation state goes up, whereas the nitrogen in nitric acid is being reduced as it gains electrons in this amazing exothermic redox reaction. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.